Let's look at some properties of sigma notation. First, we have the rule that states that the sum of a constant from I equals 1 to n is equal to n times the constant. Next, the sum of a constant times a sub I from I equals 1 to n is equal to the constant times the sum of a sub I from I equals 1 to n. The third rule states that the sum of a sub I plus b sub I from I equals 1 to n is equal to the sum of a sub I from I equals 1 to n plus the sum of b sub I from I equals 1 to n. This rule also works with subtraction, which can be seen in the fourth rule. Finally, the fifth rule states that the sum of a sub I from I equals 1 to n is equal to the sum of a sub I from I equals 1 to m plus the sum of a sub I from I equals m plus 1 to n. Let's look at an example that involves properties of sigma notation. Here we have the sum of the quantity I squared minus 7 from I equals 1 to 4. Notice that this is the difference of two terms. Recall that the sum of a difference of two terms is equal to the difference of the sum of each term. So we can rewrite this expression as the sum of I squared from I equals 1 to 4 minus the sum of 7 from I equals 1 to 4. Since we don't yet have a rule to use to rewrite the sum of an exponential expression, we just have to evaluate at each value of I. So that gives us 1 squared plus 2 squared plus 3 squared plus 4 squared. Now we have the sum of a constant. Recall that the sum of the constant from I equals 1 to n is n times the constant. So for this second term, we have minus 4 times 7. Now let's simplify. We get 1 plus 4 plus 9 plus 16 minus 28. Simplifying further, we get 2. So, the sum of the given expression from I equals 1 to 4 is 2.